GAIA, a benchmark for general AI assistance. We introduce GAIA, a benchmark for general AI assistance that, if solved, would represent a milestone in AI research. GAIA proposes real-world questions that require a set of fundamental abilities, such as reasoning, multimodality handling, web browsing, and generally tool use proficiency. GAIA questions are conceptually simple for humans, yet challenging for most advanced AIs. We show that human respondents obtain 92% versus 15% for GPT-4 equipped with plugins. This notable performance disparity contrasts with the recent trend of language and learning models, LLMs, outperforming humans on tasks requiring professional skills in, for example, law or chemistry. GAIA's philosophy departs from the current trend in AI benchmarks, suggesting to target tasks that are ever more difficult for humans. We posit that the advent of artificial general intelligence, AGI, hinges on a system's capability to exhibit similar robustness as the average human does on such questions. Using GAIA's methodology, we devise 466 questions and their answers. We release our questions while retaining answers to 300 of them to power a leaderboard available at the project's website. Diffusion model alignment using direct preference optimization. Large language models, LLMs, are fine-tuned using human comparison data with reinforcement learning from human feedback, RLHF methods, to make them better aligned with users' preferences. In contrast to LLMs, human preference learning has not been widely explored in text-to-image diffusion models. The best existing approach is to fine-tune a pre-trained model using carefully curated high-quality images and captions to improve visual appeal and text alignment. We propose Diffusion DPO, a method to align diffusion models to human preferences by directly optimizing on human comparison data. Diffusion DPO is adapted from the recently developed Direct Preference Optimization, DPO, a simpler alternative to RLHF, which directly optimizes a policy that best satisfies human preferences under a classification objective. We reformulate DPO to account for a diffusion model notion of likelihood, utilizing the evidence lower bound to derive a differentiable objective. Using the pick-a-pick dataset of 851K crowdsourced pairwise preferences, we fine-tune the base model of the state-of-the-art Stable Diffusion XL, SDXL, -1.0 model with Diffusion DPO. Our fine-tuned base model significantly outperforms both base SDXL 1.0 and the larger SDXL 1.0 model, consisting of an additional refinement model in human evaluation, improving visual appeal and prompt alignment. We also develop a variant that uses AI feedback and has comparable performance to training on human preferences, opening the door for scaling of diffusion model alignment methods. LucidDreamer, domain-free generation of 3D Gaussian splatting scenes. With the widespread usage of virtual reality, VR devices and contents, demands for 3D scene generation techniques become more popular. Existing 3D scene generation models, however, limit the target scene to specific domains, primarily due to their training strategies using 3D scan dataset that is far from the real world. To address such limitation, we propose LucidDreamer, a domain-free scene generation pipeline by fully leveraging the power of existing large-scale diffusion-based generative model. Our LucidDreamer has two alternate steps, dreaming and alignment. First, to generate multi-view consistent images from inputs, we set the point cloud as a geometrical guideline for each image generation. Specifically, we project a portion of point cloud to the desired view and provide the projection as a guidance for inpainting using the generative model. The inpainted images are lifted to 3D space with estimated depth maps, composing a new points. Second, to aggregate the new points into the 3D scene, we propose an aligning algorithm which harmoniously integrates the portions of newly generated 3D scenes. The finally obtained 3D scene serves as initial points for optimizing Gaussian splats. LucidDreamer produces Gaussian splats that are highly detailed compared to the previous 3D scene generation methods, with no constraint on domain of the target scene. Using human feedback to fine-tune diffusion models without any reward model. Using reinforcement learning with human feedback, RLHF, has shown significant promise in fine-tuning diffusion models. Previous methods start by training a reward model that aligns with human preferences, then leverage RL techniques to fine-tune the underlying models. However, crafting an efficient reward model demands extensive datasets, optimal architecture, and manual hyperparameter tuning, making the process both time and cost-intensive. The direct preference optimization DPO method, effective in fine-tuning large language models, eliminates the necessity for a reward model. However, the extensive GPU memory requirement of the diffusion model's denoising process hinders the direct application of the DPO method. To address this issue, we introduce the direct preference for denoising diffusion policy optimization D3PO method to directly fine-tune diffusion models. The theoretical analysis demonstrates that although D3PO omits training a reward model, it effectively functions as the optimal reward model trained using human feedback data to guide the learning process. This approach requires no training of a reward model, proving to be more direct, cost-effective, and minimizing computational overhead. In experiments, our method uses the relative scale of objectives as a proxy for human preference, delivering comparable results to methods using ground truth rewards. Moreover, D3PO demonstrates the ability to reduce image distortion rates and generate safer images, overcoming challenges lacking robust reward models. ZipLoRA, any subject in any style by effectively merging LoRAs. Methods for fine-tuning generative models for concept-driven personalization generally achieve strong results for subject-driven or style-driven generation. Recently, low-rank adaptations, LoRA, have been proposed as a parameter-efficient way of achieving concept-driven personalization. While recent work explores the combination of separate LoRAs to achieve joint generation of learned styles and subjects, existing techniques do not reliably address the problem. They often compromise either subject fidelity or style fidelity. We propose ZipLoRA, a method to cheaply and effectively merge independently trained style and subject LoRAs in order to achieve generation of any user-provided subject in any user-provided style. Experiments on a wide range of subject and style combinations show that ZipLoRA can generate compelling results with meaningful improvements over baselines in subject and style fidelity while preserving the ability to recontextualize. Project page, project's website. FusionFrames, efficient architectural aspects for text-to-video generation pipeline. Multimedia generation approaches occupy a prominent place in artificial intelligence research. Text-to-image models achieved high-quality results over the last few years. However, video synthesis methods recently started to develop. This paper presents a new two-stage latent diffusion text-to-video generation architecture based on the text-to-image diffusion model. The first stage concerns keyframe synthesis to figure the storyline of a video, while the second one is devoted to interpolation frames generation to make movements of the scene and objects smooth. We compare several temporal conditioning approaches for keyframes generation. The results show the advantage of using separate temporal blocks over temporal layers in terms of metrics, reflecting video generation quality aspects and human preference. The design of our interpolation model significantly reduces computational costs compared to other masked frame interpolation approaches. Furthermore, we evaluate different configurations of MoviQ-based video decoding scheme to improve consistency and achieve higher PSNR, SSIM, MSE, and LPIP scores. Finally, we compare our pipeline with existing solutions and achieve top 2 scores overall and top 1 among open-source solutions. ClipSim equals 0.2976 and FVD equals 433.054. Project page, project's website. Diffusion 360, seamless 360-degree panoramic image generation based on diffusion models. This is a technical report on the 360-degree panoramic image generation task based on diffusion models. Unlike ordinary 2D images, 360-degree panoramic images capture the entire 360 degrees times 180 degrees field of view. So the rightmost and the leftmost sides of the 360 panoramic image should be continued, which is the main challenge in this field. However, the current diffusion pipeline is not appropriate for generating such a seamless 360-degree panoramic image. To this end, we propose a circular blending strategy on both the denoising and VAE decoding stages to maintain the geometry continuity. Based on this, we present two models for text to 360 panoramas and single image to 360 panoramas tasks. The code has been released as an open-source project at Project's website and Project's website. Visual in-context prompting. In-context prompting in large language models, LLMs, has become a prevalent approach to improve zero-shot capabilities, but this idea is less explored in the vision domain. Existing visual prompting methods focus on referring segmentation to segment the most relevant object, falling short of addressing many generic vision tasks like open set segmentation and detection. In this paper, we introduce a universal visual in-context prompting framework for both tasks. In particular, we build on top of an encoder-decoder architecture and develop a versatile prompt encoder to support a variety of prompts like strokes, boxes, and points. We further enhance it to take an arbitrary number of reference image segments as the context. Our extensive explorations show that the proposed visual in-context prompting elicits extraordinary referring and generic segmentation capabilities to refer and detect, yielding competitive performance to close-set in-domain datasets and showing promising results on many open-set segmentation datasets. By joint training on COCO and SA1B, our model achieves 57.7 PQ on COCO and 23.2 PQ on ADE20K. Code will be available at the project's website. PG-Video-LLaVA, pixel grounding large video language models. Extending image-based large multimodal models, LMM, to videos is challenging due to the inherent complexity of video data. The recent approaches extending image-based LMM to videos either lack the grounding capabilities, for example Video Chat GPT, Video-LLaMA, or do not utilize the audio signals for better video understanding, for example Video Chat GPT. Addressing these gaps, we propose Video-LLaVA, the first LMM with pixel-level grounding capability, integrating audio cues by transcribing them into text to enrich video context understanding. Our framework uses an off-the-shelf tracker and a novel grounding module, enabling it to spatially and temporally localize objects in videos following user instructions. We evaluate Video-LLaVA using video-based generative and question-answering benchmarks and introduce new benchmarks specifically designed to measure prompt-based object grounding performance in videos. Further, we propose the use of Vicuna over GPT 3.5, as utilized in Video Chat GPT for video-based conversation benchmarking, ensuring reproducibility of results, which is a concern with the proprietary nature of GPT 3.5. Our framework builds on state-of-the-art SOTA image-based LLaVA model and extends its advantages to the video domain, delivering promising gains on video-based conversation and grounding tasks. Project page, project's website.